Okay, class. I saw in that last one that I did, because I'm doing this in high definition, that it really is sucking down a lot of, I mean, that was like half a gigabyte that I uploaded to YouTube. I can't do those too often. So, in fact, it'll only be like one more. But what I want to point out is this little diagram that I've got up there. This is what we're going to be doing. We're going to be putting a parallel stub match. Now, this parallel stub match that we're going to put in here is going to be purely a totally reactive stub match. And in fact, I drew like there was a load on there, but there is no load on the end. It's just shorted out at the end. And that's going to be purely resistive, because we're going to make this distance here, D2, exactly right, so that it's a purely reactive stub. And the distance that we put it back, we're going to only have to get rid of the reactive part, because by the distance we put this back, we'll bring this all the way back to the 1 plus J0 circle, right? So that's what we're trying to get to. We're trying to get to the 1 circle. So here's how you do it. Now let's say that we are at the load, and we know that this is the load right here. That's the load impedance right there. But since we're going to put it in parallel stub matching, right? We're going to put this in parallel to the main circuit that we've got there. We have to work with admittances rather than working with impedances on the Smith chart. So the first thing that we want to do, step 1, is we're going to go to the other side of the chart. So we started off here, and that was our impedance. Now we're going to go over to our admittance, and you can see that the admittance that I've got here is 1.5 plus J 0.85, right? So now what we want to do is we want to follow the the constant VSW curve around until we get to the 1.0 circle. And what do I mean by the 1.0 circle? Well, this is my 1.0 circle, isn't it? I'm just going to put some dotted lines here so that everybody can see where my R equals 1 circle is. And so that's what we're doing. We're trying to get back to that circle, so that right now, if we go, and which way are we going? See what we're doing? We're going clockwise, right? We're going clockwise around the VSWR circle. So that means we're going toward the generator. We're going away from the load toward the generator. And so that's what we're doing, and we want to find out how much that is. Well, we know that right here we can read off where we are as far as wavelengths go. And then if we drop another line down straight off here, right through the center, right through that point off to the side, I'll try to do it small. We now have these 2 lines. What is this distance here? In wavelengths, this distance, and of course it would depend on the frequency and you know, what your wavelength is and what type of you know, thing. Are you shooting it through the atmosphere? Are you shooting it down a coaxial cable? What? So, but this distance right here, you can see that we start off, if we go to wavelengths, this is 0.193, 0.193 wavelengths there. And then if you come all the way out here, we've got 0.35 wavelengths. So I have 0.35 wavelengths minus 0.193 wavelengths, and that would be 0.158, right? 0.158 wavelengths. I hope I did that right. Maybe I didn't. Right. Yeah, because that's 0.2. Oh, no, that's 7. Oh, no, wait. 7.15. 7. Anyway, it's supposed to be a 7. So that's the wavelengths, but what is that distance? That's D1. So D1 is 0.158 wavelengths. I'm saying 8. All right. So we're back from the load. We've gone back that far. So it's just basically we've gone back from the load along the line that far, and that's the distance back. Now, how long do we make the stub? That's the other question, because if you see right here at this point, what is the value of that? Well, we know it starts with 1, right? Because it's on the 1 circle. The R equals 1 circle. So we know it starts with 1, but then, and we know that it's negative, right? So let's just follow these lines right here. See that line? We can follow that down. Well, that's 0.7 and that's 0.8. So this line right here is 0.75. So 1 minus J, 0.75. Now, how do we get that to be 1 plus J0? This is where we're going, isn't it? Remember, that's the target, right in the middle. 1 plus J0. You know what I could do? I could take this 1 minus J 0.75, and I could add J 0.75 to it, right? Wouldn't that give me 1 plus J0? Does everyone see that? So all we need is we just need this. We need 0 plus J 0.75. Now, where is 0 plus J 0.75 on this? Where is 0? Well, 0 is on the very outside, isn't it? 0 is on the very outside. Now, plus J 0.75. Well, plus would be on the top side of the Smith chart, and 0.75 would be right here. Does everyone see that? Now, let's just draw a line through there. And where are we coming now for this? We're coming off of our y equals 0. So we're coming all the way around here. There you go. So we're coming off the z equals infinity or y equals 0 line, and we're coming all the way around here. So let's see, we can actually just measure that. It starts with 0.25. And so we're going 0.25 because we've come all the way over to here. So that's 0.25. So 0.25 plus 0.102. 0.25 plus 0.102. That gives me 0.352 lambda. So we have to make this distance here 0.352 lambda. Did I do that right? Three other side, you have 1. And then that's 0.75. Yep. Okay, I did everything right. So those are the 2 lengths that you would have if you were parallel stub matching. Remember, step 1, find small z sub L and plot it. Step 2, since you're parallel stub matching, find the impedance, right? Once you found the impedance, then you want to follow the impedance around until you hit the R equals 1 circle. And that's this black circle here, not the red one. The red one is the constant VSWR circle. of 2 point, whatever I came to, 2.25. And you can read that right off the bottom here. So I hope everybody has gotten these two things. And then when I had the 1 plus, I'm right here. How do I get down to that point? Well, I subtract, I add, because I have a minus j.75, I add a plus j. Now, when I say I'm adding this right here, what am I really adding? I'm adding 0 plus j.75, aren't I? It just so happens that the 0 line for the resistance is around the outside, right? 0.2, 0.10. So it's around the outside, and that's the point you've got to get to. You shoot through that, and then you've got to subtract off that, and that's your line. Okay, I hope I haven't used another ½ gigabyte, but that ends our class lectures. I'll give 2 more lectures on Maxwell's equations, which you won't be assessed on, but you can view those at your leisure if you ever want to. All right. Had a great semester, and we'll talk again on the final.